Welcome to the deep dive. Ever think about how things are actually held together? Skyscrapers, bridges, even your car. So much relies on welding. And today, we're looking at the really precise tools that make sure those welds are safe. Specialist gauges. Our mission is basically to show you how these tools ensure quality and safety, turning complex measurements into something, well, understandable.
Absolutely. And, understanding these tools is so critical. They're the bridge, really, between a design on paper and the physical thing. It's about making sure what's planned is actually built right, robustly, reliably, no guesswork allowed, not when safety's involved.
Okay, right. So let's unpack this a bit. Welding isn't just sticking metal bits together, is it? It's about creating these incredibly precise joints, connections that need to last under all sorts of stress. So how do we know they're precise? How do we measure it?
Exactly. And that's where these specialized gauges are key. What's really fascinating is how specific they are. Take high-low gauges, for example. They measure mismatch. That's when the two pieces aren't quite lined up perfectly before you weld.
Okay.
Like an uneven step.
Precisely. And also the root gap. That's the tiny, tiny space you deliberately leave at the bottom of the joint. Might sound minor, right? But get the mismatch or the gap wrong, and bang, you've built in a weak spot. A massive stress point. Which
could lead to failure way down the line. Makes sense. Small error, potentially huge consequence. And I hear some gauges are really versatile, like a multi-purpose welding gauge. Yeah. What kind of stuff can that measure?
Oh yeah, the multi-purpose ones are real workhorses. Usually tough stainless steel, great for general fabrication work. They can quickly measure a whole range of things, like the angle of preparation, how the metal edge is shaped before welding, which is crucial for a good joint. Then there's fillet weld leg length, the size of the weld's sort of triangular shape, and throat size, which is often the thinnest, weakest part of that weld, and even checks misalignment again, making sure parts line up. And you get metric and imperial. Wow, like a welder's Swiss Army knife. You mentioned misalignment there again. How does a tool like that actually detect something so, well, subtle? And what else can it find that maybe you wouldn't just see by looking?
Good question. Let's maybe look at a specific one, like the TWI Cambridge multi-purpose gauge.
Yeah.
It's quite clever. For linear misalignment, you just rest the gauge edge on one piece, then rotate a little segment until a pointer touches the higher piece. Gives you the exact difference.
Huh. Simple but effective?
Yeah. And it can do more, like measure excess weld metal root penetration on certain types of welds. You want enough penetration, but not too much sticking out the back. And crucially, it can even spot things like pitting or mechanical damage. It finds the lowest point of a defect, stuff that could be invisible otherwise.
So it's digging deeper than just the obvious geometry, finding hidden flaws. Now, I heard there's a calculation involved sometimes for something called excess weld metal. How does that work? Sounds quite smart.
It is, yeah. It's about getting the balance right. You don't want too much weld metal, adds weight, can create stress points, but definitely not too little. So this same gauge can measure the fillet weld leg length, say, up to 20 millimeter or an inch.
Okay.
And it has this little sliding pointer to measure the actual throat thickness. Again, up to maybe 20 millimeters or 3/4 of an inch. Now, there's a quick calculation you can do. Measure the leg length, multiply by 0.7, that gives you a sort of ideal throat thickness.
Right, like a target number.
Exactly. Then you compare that to the actual throat thickness you measured. The difference tells you if you have excess weld metal. So, say a 10 millimeter leg length, multiply by 0.7 gives 7 millimeters. If your actual measured throat is 8 millimeters, then 8 minus 7, you've got 1 millimeter of excess weld metal.
Got it. Simple math, but based on precise measurement. Gives you a real number for quality control. Although you mentioned it might assume a nominal design. What's that about?
Oh, yeah. Just means for some measurements, like the throat thickness calculation, it's often based on the intended design size rather than accounting for every tiny variation. It highlights that you need to know the specific tool and its application, its limitations.
Understood. So wrapping this up then, what's the big takeaway for you, the listener? These specialist gauges, they really are the unsung heroes of welding quality control, aren't they? They make sure every joint, every structure is aligned, strong, fundamentally safe, taking invisible details and making them measurable.
Absolutely. The precision you get from these, well, seemingly simple bits of metal is quite remarkable when you think about it. And maybe here's a final thought to leave you with. Just consider how many everyday things, bridges you cross, buildings you're in right now, rely completely on these precise, often totally hidden measurements for their stability, for your safety. Makes you wonder what other hidden tools or processes are out there, quietly ensuring the integrity of our world that we just never, ever think about.